And basically, this is a situation where the exponent on the sine is cubed and the exponent on cosine is just whatever. So I wrote here odd. So when you have an odd exponent, this is on the table. This is just the procedure you do. Basically, if you have a situation like this and the exponent on sine is odd, the procedure is you pull out a sine like this. So now you write it as sine squared with the sine out here. And then at this point, you want to use your trig identity. So with the sine squared here, you want to use the trig identity to make it 1 minus cosine squared. And essentially at this point, the reason why this is useful is because at this point, we can actually use u substitution. Because if you see, we have this sine x dx right here that we pulled out. And that's useful because remember that the derivative of cosine is sine, right? I mean, technically speaking, the derivative of cosine is negative sine, but that doesn't matter, right? A negative sign, it doesn't matter. You can just multiply by a negative, that's fine. And so that's why this is useful here, right? So we use the Pythagorean identity to write it like this. And now we have a bunch of cosines all being multiplied, and we have the derivative of cosine right here. So that's why now we want to do a u substitution and do u equals cosine x, right? Because then the du is negative sine dx. And look, it's right there, right? So we can substitute it in. So that's why this is the procedure here, right? You have an odd one, you take it out, you do Pythagorean identity, now you can do a u substitution. And then once you do that, you plug in your u's, and look at this now, right? Easy polynomial integral. You can just distribute this, and now everyone knows the antiderivative of this, right? You do, this should be 1/5, right? It's just the reverse power rule at this point, so this would be like a 1/5. 1/5 u to the 5th minus 1/3 u to the 3rd plus c, and then you can substitute back in for u to get the final answer there. Okay, so that was the procedure for the first problem.